Lesson 8.1 is called complex numbers. So when we talk about the complex numbers, we have numbers like 2 plus 3i. So this is an example of the complex number, and this number has a real part. So this number 2 represents the real part of the complex number, and then this 3i part of the number represents the imaginary part of the complex number. And then I represents the imaginary part. So where does the I come from? When we have a square root of 25, because it is 5 to the second power, we know that the principal root for square root of 25 is just 5. But when we need to simplify square root of negative 25, whenever we have a negative sign inside a radical, we will get an I outside. So this will just return a 5i. So whenever you're trying to take the square root of a negative number, you will have an I outside of the radical. Let's do one more example. If somebody asks me to simplify square root of 16, my answer is 4. But if somebody asks me to simplify the square root of negative 16, so positive number 16 changed to a negative 16, a negative in a radical means an I outside, and square root of 16 is just 4. So this is how I can simplify square root of negative 16 to this formula. So what we want to do is now for the rest of the video, we will solve the examples from our 8.1 homework. 8.1 homework about complex numbers. We have total of 23 problems. And some of these problems are simplifying the complex numbers, some of them are adding. So let's get started with question 1. For question 1, it asks me to simplify square root of negative 144. If it was positive square root of 144, my answer would be 12. But because of the negative sign, the answer will be just negative 12i. So a negative inside the radical will return an I. The square root of 144 is 12, because 144 is 12 to the second power. And then when I check this answer, number 1 is correct. For number 2, this is not a perfect square number anymore. First of all, I know that I'm going to get an I as a part of my answer, because whenever we have a square negative sign under the radical, we will get an I. We have to simplify the 28. 28 is 4 times 7. 4 can go outside of the radical as 2, but then the 7 is not a perfect square number, so it's going to stay here. Again, how did I get this? 28 is 4 times 7. 4 goes outside as 2, and 7 inside the radical. You can definitely leave your answer like this, or the better way to express this answer is we like to keep the 2 at the beginning and I in the middle and radical at the end. So this is how I can give my answer to number 2. For number 3, there are 2 negatives going on. First negative has nothing to do with my simplification, so it comes with me wherever I go. And now for the negative sign inside the radical, I will get an I outside of the radical. And now I need to just simplify this number, square root of 108. 108 is 36 times 3. So 36 will go outside as 6, but then the 3 is not a perfect square number, so it will stay here. Again, I can leave my answer like this, or I can make it look better by putting the 6 to the front, I between the number and the radical. But let's check our answer like this and see what does my MATLAB say, if it even accepts this answer. Now, when we want to multiply them, we're not going to multiply them first and then find the answer, but instead, we're going to simplify each one individually and then multiply. So in this case, we want to multiply square root of negative 10 by square root of negative 10. So let's go to a bigger place. And then question on that homework is, I have this square root of negative 10 will be multiplied by square root of negative 10. So let's simplify this one first. A negative inside a radical means an I outside. And 10, there's nothing I can say from 10. 10 is 2 times 5. None of the numbers repeat themselves, so 10 is going to stay inside the radical as it is. Similarly here, because it's the exact same number, I don't have to think much. It will return the same result, I radical 10. Now, I times I, when we multiply the I and I, we will get I squared. And square root of 10 times square root of 10 is just 10. So because radical times radical, the radicals will disappear and you will just get 10. And I squared in math is always equal to a -1. So basically your question becomes, what is -1 times 10? And the answer will be a -10. So when you see this problem on the homework, if you get a similar number, you just have to type here, the answer is -10. And then when you check your answer, it will be correct. Similar question, the numbers have changed as -28 and -3. So let's go here, and then we're going to just open some space here, and then we want to now simplify square root of -28 was the first number, and we're trying to multiply it by square root of -3. Again, we're going to simplify each one. This one, the negative inside the radical means an I outside. And then for 28, let me show you this time how I do simplify square root of 28. It's 4 times 7. And then 4 goes outside is 2. So this just becomes 2i and 7 stays. So when you simplify square root of -28, the answer is 2i radical 7. And then for this portion now, a negative inside the radical means an I outside, and then the 3 will stay. So when you simplify this one, you only get I radical 3. Now, 2i times I, because we can only multiply the outside numbers by another outside number. 2i times I is 2i squared. And then root 7 times root 3 is, we can combine them under one radical. Root 7 times root 3 is just 21, because 3 times 7 is 21. We always have to replace the I squared with -1. We can never leave the I squared as it is. We have to always replace it with -1. And then I'm going to multiply it by square root of 21. So these two whole numbers, when I multiply them, they just give me a -2. And then the radical 21 stays because there's no way I can simplify this further. So in this question, when I go to homework, I will tell them that this is the simplified version here is -2. I will make that -2 is square root sign in 21, and that's how I'm going to solve this question for number 5 on the homework. For number 6, again, we will simplify each one, and then we will perform the division. So I want to divide square root of -72. Again, I want to open space here. So the question is, at the top, I have square root of -72. And at the bottom, they gave me a 12, square root of 12. So we simplify each one individually. A negative sign in a radical means an I, and then 72 stays here. But 72 is 36 times 2. So when you have square root of 72, you have square root of 36 times 2. And then 36 will go outside as 6, and then the 2 is going to stay. So when you simplify this, I stays outside, and then 6 will be outside, and radical 2 is going to be at the end of the expression. At the bottom, there is no negative sign, so there is no I showing up. And then for 12, 12 means 4 times 3. So when I take the square root of 12, the 4 is going to go outside as 2, and then the radical 3 is going to stay in the denominator. So this one is 2 radical 3. Now, we can only divide outside numbers by outside numbers. So when you divide 6 by 2, you will just get 3. And then you have an I left at the top, and a radical 2 at the top, and then you have a radical 3 at the bottom. In math, we're not allowed to leave the radicals in the denominator, so we will have to multiply top and bottom by root 3 to rationalize the fraction. I have the 2i, and then when I multiply these two radicals, they will give me a square root of 6. And then here, when I multiply them, root 3 times root 3 is just 3. This allows me to simplify the top 3 by the bottom 3. So my answer becomes as simple as I radical 6 for this question. So when I go to homework, I will tell them that the expected answer here is I radical 6. And then I can check my answer now. For question 7 now, it's no more simplification, it's addition. When we add the complex numbers, we add the real parts with real parts, imaginary parts with imaginary parts. So the real part on the first number is 8. Real part on the other number is also 8. So 8 plus 8 is 16. So I just combine the real parts. Now I'm going to combine the imaginary parts. Positive 6i and negative 5i. When I combine them, I will have a total of positive 1i. So this is how I am going to get the answer to this addition problem. Now it's a subtraction, but we can handle all subtraction questions like addition problems. So let's actually take this question to a bigger spot. And then here we will use a bigger space. So before I combine the like terms here, like the other problem, I want to rewrite the question. I'm going to rewrite the first part without a parenthesis, so I can rewrite it as negative 4 plus 2i. On the second part, whenever you have a negative before any parentheses, everybody changes sign. So instead of a negative 6, I will copy a positive 6. Instead of a 2i, positive 2i, I will copy a negative 2i because a negative before a parentheses changes everybody's sign. Now, again, we will combine the real parts with real parts. So these are the only two real parts. Negative 4 and 6, when I combine them, the answer is 2. And then 2i, positive 2i, and negative 2i, when I add them on together, it's total of 0i. But I don't need to write the 0i. The expected answer will be here just 2. So when I go to homework, I will tell them that imaginary parts cancel out, and all I get is 2i as an answer. So let's just do one more time, addition and subtraction combination. So for this problem, there are actually 3 numbers here. Okay. So for the first one, I am going to keep the negative I and negative 4 the same. But for these two, since they have a negative before the parentheses, everybody is going to change signs. 6 is going to become a negative 6. Negative 7i will become a positive 7i. Similarly here, because we have a negative before the parentheses, 4 will be copied as negative 4. Negative 6i will be copied as positive 6i. Now I will combine the real parts with real parts, imaginary parts with imaginary parts. This is the real part here, negative 4. Negative 6 is the real part, and negative 4 is the real part. So when we combine these 3 negative numbers, that's a negative 10, and that's negative 14 total. Now, if you look at the imaginary parts, we have negative 1i here, positive 7i here, and positive 6i here. 7 plus 6 is 13i, and then when we subtract this, it will be total of positive 12i. So the expected answer will be here, negative 14 plus 12i. So I here type negative 14 plus 12i, and then when you shift the answer, it will be correct. Okay, now this question asks me to multiply the complex numbers. So we will definitely need bigger space than what my MATLAB shows me. So I'm going to go ahead and open some space. I want to multiply 6 plus 2i with 9 minus 4i. So 6 plus 2i. We're going to multiply this complex number, 6 plus 2i, by 9 minus 4i. 9 minus 4i. So let's perform how we're going to multiply them. We're going to use the process called FOILing. So 6 times 9 is 54. 6 times negative 4i is negative 24i. And then 2i times 9 is 18i. And then 2i times negative 4i is negative 8i squared. And then we're just going to write negative I squared. It's important, but as soon as we write this, I will erase the I squared because this is not acceptable in math class. Every time we see an I squared, we have to replace it with negative 1. In math class, I squared is always equal to a negative 1, and we're not allowed to keep the I squared. We must replace it all the time by a negative 1. So here, 54 will be copied, and then these two imaginary parts, negative 24i and positive 18i, that's total of negative 6i. And then negative times negative here is positive, and 8 times 1 is 8. Now, these two numbers will be combined, and that gets me as 62 minus 60i is the expected answer for this problem. We're going to put here 64 minus 6i. Let me double check. 6i, 62 minus 6i. What we've got, 62 minus 6i is what we've got for the multiplication question. So here, we have a similar problem, another multiplication, but instead of showing the problem as 2 minus 5i times 2 minus 5i, they're asking us 2 minus 5i to the second power. So we're going to go here, and then we will write 2 minus 5i to the second power, 2 minus 5i to the second power, what we want to solve, which means the exact same thing as 2 minus 5i times 2 minus 5i. So we're going to repeat the previous problem's method one more time. 2 times 2 is 4. 2 times negative 5i is negative 10i. Negative 5i times 2 is negative 10i. Negative 5i times negative 5 is I is plus. Negative times negative is plus. 5 times 5 is 25. I times I is I squared. But remember, immediately we get I squared, we must erase the I squared. And always, instead of I squared, we need to plug in a negative 1. This allows me to write 4, and then negative 4, 10i, and negative 10i, that's total of negative 20i. And then here, positive times negative is negative, and then that's just a 25. So now I just need to combine my real parts, which will be total of negative 21 minus 20i is what I need to give them as an answer for this question. Negative 21 minus 20i is what I need to give them for this question. Question 12 is another multiplication one, so I will let you tackle this. Here, when you have three numbers, first multiply the 8 plus 7i by 8 minus 7i. So let's do this. So there are three numbers with this homework problem that we must multiply. According to this problem, first number is I, second number is 8 plus 7i, third number is 8 minus 7i. So what I'm going to do is first, I am going to multiply 8 plus 7i by 8 minus 7i. So I'm picking these two first to simplify. 8 times 8 is 64. 8 times negative 7i is negative 56i. These two will give me a positive 56i. And then these two will give me a negative 49i squared. But again, remember, I am not allowed to keep the I squared. I will erase it right away. And instead of I squared, I'm just going to plug in a negative 1. So when I continue now organizing, the good thing is imaginary parts will cancel out because one is negative, one is positive. And now we have a 64 here. Negative times negative is positive, and 49 times 1 is just 49. And when we add them up, 4 plus 9 is 13, 1 is the carry, that's 10. And then this is the expected answer when we multiply these two on it. But remember, this question has an additional complex number here at the top, I. So now I'm going to multiply my answer by I. I times 113 is 113i. So our answer changes from pure real to pure imaginary now. So here, I am going to tell him that the expected answer for this question is 113i. The order is not important. You can put the I first if you like. It will be still correct. Now we're going to learn how to do division with complex numbers. So I want to divide 6 plus 5i by 1 plus 7i. So I definitely need a bigger space than what my answer gives me, or I can't do a lot of work in my head for this question. So 6 plus 5i is what we have at the top. 6 plus 5i. And then what we have at the bottom is 1 plus 7i. Okay, there is no rule to divide a complex number by another complex number. Instead of dividing, we are going to actually multiply numerator and denominator by the complex conjugate of this number. Complex conjugate of this number means the exact same thing, but just switch the sign with the opposite. So if we have 1 plus 7i, we're going to multiply top and bottom by 1 minus 7i. So top and bottom will be multiplied by 1 minus 7i to perform this division. Now, actually, I have two multiplication to perform for every division problem. 6 times 1 is 6. 6 times negative 7i is negative 42i. 5i times 1 is just 5i. And then 5i times negative 7i is, that's negative 35i squared. But remember, I am not allowed to keep the I squared instead of I squared. I need to just plug in a negative 1. So negative 35 times negative 1 is just a positive 35. Simply, this tells me that I am just going to, now, whenever I need to multiply a positive 5i by negative 7i, whatever the sign I'm receiving, I will just switch it and I will just multiply the numbers 5 times 7 and then I will get the answer next time. So let's repeat what I'm saying here. 1 times 1 is 1. 1 times negative 7i is negative 7i. 7i times 1 is positive 7i. So here, positive times negative is negative, but because of the I squares, I will change it to a plus, and 7 times 7 is 49. If you don't understand this shortcut, do it as negative 49i squared, replace the I squared with negative 1, and then you will see that eventually you will get the same answer as with me. Now, so 6 plus 35 is a total of 41. And then these two imaginary parts, when we combine them, that's a negative 37i. 37 and 5, when we combine them, that's a total of 42. Here at the bottom, negative 7i and positive 7i cancels out, and we get 1 plus 49, which is 50. So this is what I get as an answer for this division problem. So we're going to go here, simplify your answer, use integers or fractions for any numbers in the expression, type your answer in the form of a plus bi. So I'm going to first try to enter my answer to this way. I'm just going to write 41 minus 37i to see if my MATLAB will accept this. 37i, and then the denominator here is 50. If it doesn't accept this answer, I will write them as two separate fractions. See, although your answer is equal to the correct answer, this is not the correct form. So what they are really saying is we need to change this as 41 over 50, that's the real part, and then minus imaginary part is 27i over 50. This will be the imaginary part, and I can check my work. I'm going to perform one more division for you. Question 15 is still division, so let's practice one more time. And then our question is this time 1 plus 7i. We have 1 plus 7i. And then we want to divide it by 1 plus I. So again, there is no way to directly divide the complex numbers. Therefore, what we have to do is we need to multiply top and bottom by the complex conjugate of the denominator. Since the denominator is 1 plus I, we're going to multiply the top and bottom by 1 minus I. So 1 times 1 is 1. 1 times negative I is negative I. 7i times 1 is just 7i. And then 7i times negative I is negative 7i squared, which will just give me positive 7. Do the same thing here. 1 times 1 is 1. 1 times negative I is negative I. Well, I times 1 is positive I. I times negative I is negative I squared, which will be just a positive 1. So 1 plus 7 is 8. And then total of 6i here. This cancels this, and now we just get 2. since my MATLAB doesn't like this answer, they want me to give the answer as 8/2 plus 6/2. And if I simplify further, 8/2 is just 4, and then 6i divided by 2 is just 3i. So this will be the expected answer that they want here, 4 plus 3i for this question. Now, with question 16, we want to divide 5 by -i. That's another division problem, but it's a little bit different format than what we have seen so far. It's 5, the question is 5 divided by -i. So when I need to divide 5 by -i, the complex conjugate of denominator is now just positive I. So we're going to just multiply top and bottom by positive I. So the numerator becomes 5i, and the denominator becomes negative times positive is negative, I times I is I squared, so we have a negative I squared. But remember, we're not allowed to keep I squared with us. I squared will always change with a -1. That's what I squared means. I squared is always equal to -1. Numerator stays, and on the denominator, 2 negatives will change it to plus. And then when we divide 5 by 1, my expected answer will be just 5i for this question. And then this is how we're going to handle question 16 on the board. For number 17, now we're going to multiply top and bottom by -7i, and you will find the answer. Now we have some equation problems to tackle, which your results, they are going to involve the complex numbers. So when we need to solve x squared equals -121 using the square root property, what they mean is, this is actually a Cauchy algebra concept. We're just reviewing it here. So what I'm going to show you is, if the question was x squared equals to +121, and I need to solve for x, I was going to just take the square root of each side, and then this just becomes x. But then square root of 121 is 11, but it always returns two answers, +11 and -11. So this equation, x squared equals 121, has two solutions, -11 and +11. However, that's not the problem here. In this problem, x squared is set to a -121. So +121 has been replaced with -121. The method will be the same. We're going to still have to take the square root of each side. This will still just return me an x. But when we simplify square root of -121, it's not 11 anymore. It's 11i now. But it will be still positive and negative. So this question is going to return me two solutions. One solution is -11i. The other solution is +11i. So this will be the difference between this question and this question. So here when you go to homework, we will tell them that one solution is -11i, the other solution is +11i, and then that's how you get the answer to this question. Again, this one, solve this quadratic equation. If x squared plus 12 is set to 0, x squared plus 12 is set to 0, x squared plus 12 is set to 0, I can just subtract 12 from each side, and I can get x squared is equal to -12. Then we have to take the square root of each side. This just gives me an x, and then a negative inside the radical will return an I outside. And for 12, we can just replace it as 4 times 3 for now. So x will stay, I will be here, and 4 is going to come outside as 2, and 3 will stay here. But don't forget, we will always have two solutions for these quadratic equations. The expected answer is positive and negative to either 3. There must be a button is plus and minus, so I don't have to repeat my solution twice. I can tell them that the solution is positive and negative to either radical 3 for this question. Okay, the last thing we're going to tackle with this homework is powers of I. So how will I simplify the I to the power of 13? So in order to understand that question, I want to start with the powers of I from the beginning. So when I have I to the power of 0, it doesn't matter what the base is. Any number to the power of 0 is always 1. If we have I to the first power, the answer is I. If we have I to the second power, this is one of the very important rules for this subject. It's always equal to -1, and everybody has to accept this. I squared is always equal to -1. Now, when I need I to the third power, so I to the third power is I to the first times I to the second power. So when we multiply these two results, I cube will be equal to a -I. But the good thing is I to the fourth is always I squared times I squared, because in math, when you're multiplying the exponents, you add the powers. And then I squared is equal to -1. I squared is equal to -1. So when you multiply these two negative numbers, the result is +1. So this means I squared is -1, but I to the fourth power is +1. So every time you have I to the 8, the answer will be 1, because 8 is a multiple of 4. Anytime you have I to the 12, the answer will be 1, because 12 is multiple of 4. But every time you have I to the 6th, the answer will be -1. Or when you have I to the 10th, the answer will be -1. So when you have multiples of 4s here, the answer will be 1. When you have just the even powers of the I, which is not multiple of 4, the answer will be -4. So when you have I to the power of 13, you're going to see what is the highest multiple of 4 this number keeps. So that's I to the power of 12 times I to the first power, because 12 plus 1 is still 13. The good thing about this part is this is simply just equal to a 1, because 12 is a multiple of 4. But I to the first power is just I, so the expected answer will be here just equal to an I for this question. I to the 13 will be always equal to an I. These questions, the result is either a -1, +1, I, or -I. There is no other answers than these options. So see, 48 is a multiple of 4. I don't even have to do any work. I know that this will return to a 1. For the next question, we have I to the power of -9. Let's just open some space here. So we have I to the power of -9 that we have to simplify. In exponents, whenever you have a negative power, you always first write your question as 1 over I to the power of 9. So this negative in the exponent will give you a 1 over at the top, and I to the power of 9 will move to the bottom. So this one stays the same, but remember, this can be rewritten as I to the 8th power times I to the first power, because 8 plus 1 is just 9. And according to the rules, whenever we have a power which is multiple of 4, this whole thing just becomes as simple as 1, and then this is just the I. So what we have is the top is 1, the bottom is I. We're not allowed to keep an I in the denominator, so we will have to multiply top and bottom by the opposite of this number. So opposite of I is -I. So the numerator is just -1I. Denominator is -I squared. Since I squared is equal to -1, two negatives will change it to plus, and the numerator is going to stay as -1I. And -1I divided by 1 is just -1I, which is just -I for this problem. The last question on the homework is this 1 over I to the power of -23. So it's a combination of a negative power and a fraction. So we need to simplify 1 over I to the power of -23. Now, if I has a negative power in the denominator, this means this guy wants to switch sides, so it wants to go to the numerator. So you can simply move to top floor as I to the 23, and then the 1 is going to stay here, but it won't change anything, and there is nothing left at the bottom. So simply, we want to simplify I to the power of 23. So I'm going to see what's the highest number that 23 holds in it, which is a multiple of 4. I know that 23 is 20 times 3. So when I have I to the power of 23, I can write it as I to the power of 20 times I to the power of 3. Since this is a multiple of 4, I don't have to worry about this part anymore. It's just equal to a 1. And I cube, remember the original chart, we said this is 1, I to the first power is I to the second power is always equal to -1. I to the third power will be the product of these two things, which is simply I. And we said that I to the fourth power is a +1. So I cubed is -I according to this chart. So when I multiply these two numbers, my answer will be a -I for this one. And this is going to be the last example for section 8.1. And this is all we have to know for 8.1. Good luck with the homework.